solving this mathematics. Here we can write this given equation as x cubed minus x squared equals to 48. But let's pause for a minute. What if we do this by inspection and you plug in x equals to 4? It's going to work. You can try that. But what about we have more values, more solutions for x? This is why we have to do this. Now, we have x cubed minus x squared equals to 48. Rewriting this here, we're going to have x cubed minus x squared minus 48 equals to 0. Now we have this. Here, we can write 48 as saying 64 minus 16. What prompted this? This is because here we're having x to the power of 3. So we can think in this line as a value in which we can have a perfect square one and you can have a cube value. So here I'm going to have x to the power of 3 minus x squared 64. This is going to be negative 64 minus 16 equals to 0. And from here, I can split this as saying s to the power of 3 minus s to the power of 2 minus 64 plus 16 after distributing equals to 0. Here I'm going to have s to the power of 3 minus s squared. 64 can be written as 4 to the power of 3. So we have minus 4 cubed, while 16 can be written as the square of 4 equals to 0. Here we have two terms. We have the cube and we have the square. Let's group them together. So here I'm going to have x to the power of 3 minus 4 to the power of 3. Then I'm going to have minus x to the power of 2 plus 4 to the power of 2 equals to 0. Here, let's put this in parentheses. To make more sense, you're going to have x to the power of 3 minus 4 to the power of 3 minus x to the power of 2 minus 4 to the power of 2 equals to 0. But before we proceed, I want you to recall these two rules. Recall that if we have a to the power of 3 minus b to the power of 3, this is the same thing as saying you have a squared plus ab plus b squared. And here we have a minus b. And for the second term, that is the difference of two squares. If you have a squared minus b squared, this is going to be a plus b, a minus b. So we have these two conditions in which we're going to plug in. Now, let's plug in when we have difference of cube. So this first expression can be written as saying a x squared. Here I'm going to have x squared plus, this is going to be my a, this is going to be my b, plus 4x plus 4 squared. And here I'm going to have x minus 4 minus, this is the second term, which is the difference of two squares. Here I'm going to have x plus 4, x minus 4, all equals to 0. Moving to the next slide, I'm going to rewrite this previous equation. In the previous equation, I have x squared plus 4x plus 4 squared. Also, I have x minus 4. This was for the first expression. And for the second expression, I was having x plus 4, x minus 4 equals to 0. Looking at this given equation, you can see that x minus 4 is common to both sides. Then let's factor it out. Here I'm going to have x minus 4. And here we're going to have the remaining value here, which is s squared plus 4x. 4 squared is going to be 16. And also here I'm having this, which is minus x minus 4 equals to 0. Let's simplify what we have in the parentheses. Here we have x minus 4, and in the parentheses, let's bring it out. Here we have s squared plus 4x plus 16. Let's distribute the negative sign, which is going to be negative x plus 4 equals to 0. Now, simplifying further, here I'm going to have x minus 4. In the parentheses, I'm going to have s squared. 4x minus x is going to give me plus 3x plus 16 plus 4. Oh, this is x plus 4. So this is going to be x minus 4. So here I'm going to have x minus 4. So plus 16 minus 4 is going to be plus 12 equals to 0. Now here we have two values in the parentheses. So the first value for x is we can have x minus 4 equals to 0. And here we have s squared plus 3x plus 12 equals to 0. So here, simplifying further, here we can say the first solution for x, which is going to be s1, equals to 4. What about the remaining solution? Here we have s squared plus 3x plus 12 equals to 0. In the next slide, I will be getting the other solution for x. So recall that we have x1 to be equals to 4. And here we have s squared plus 3x plus 12 equals to 0. So here we have, simplifying this further, using the quadratic formula, here I can say that my a equals to 1, which is the coefficient of the quadratic equation. My b equals to 3, and my c is equals to 12. Now using the quadratic formula, where I'm going to have x equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. Let's plug in. Here, my x is going to be minus b, which is 3, plus or minus the square root of b squared, which is going to be 3 squared, minus 4 times a, which is 1, times c, which is 12, all over 2 times a, which is 1. So here, my x is going to be minus 3 plus or minus the square root. 3 squared is 9. Here we have 4 times 1 times 12. 4 times 1 times 12 is going to be negative 48 all over 2. And here, the value of my x is going to be minus 3 plus or minus square root of 9 minus 48 is going to be negative 39 all over 2. Now recall, class, that if we have negative 39 can be written as negative 1 or negative 39 times negative 1. And square root of negative 1 in mathematics is going to be a complex root, which is I. So here I'm going to have x to be equals to negative 3 plus or minus 39i. This is a complex number over 2. Here you can say x equals to negative 3 minus 39i over 2. Or you can say that negative 3 plus 39i over 2. Therefore, we have that our x1 equals to 4. By inspection, initially, if you plug in into the given equation, it's going to work. And here you can say that x2 is going to be, simplifying further, negative 3 over 2 minus 39i over 2. And here, my x3 is going to be negative 3 over 2 plus 39i over 2. So these are the equation. These are the answers for my S. These are the solutions for S. If you have any suggestion, you can put it in the comment section. Thank you very much. So here you have some of my videos you can watch on YouTube. This is my channel, Ajadi Math Class. If you go to my channel on YouTube, I have so many videos that you can watch. You see? So I'm going to be playing some of them in which you can benefit from.
Slide. So here we factor out 2a plus 1 roots of a and b. So here, looking at the question, here we have a squared plus 2ab plus b equals to 22. Here we have a squared plus, you can see that b is common to both sides. Then you can factor that out. In the parentheses, you're going to have 2a plus 1 equals to 22. Then the next thing to do here is to multiply this given equation by 2. If you do that, here you're going to have 2a squared plus 2b into parentheses 2a plus 1 equals to 44. So here you can have a squared. I'm going to introduce plus a negative a. So here plus a negative a plus 2b into parentheses 2a plus 1 equals to 44. If you look at these two, they can possibly cancel out whereby you have this given equation back, the previous equation back. So I intentionally introduce those variables just to factorize out. So looking at these two terms here, you can factor out a, and in the parentheses, you're going to be left with 2a plus 1. Here we have from here plus 2b into parentheses 2a plus 1, and this negative left with a plus 2b. So we have a plus 2b minus a equals to 44. And from here, the next thing to do is multiply this given equation also by 2 again. So here we're going to have 2 into bracket 2a plus 1. We have a plus 2b minus 2 times a, which is 2a, equals to 88. So here, subtract 1 from both sides. So from this given equation, we can write this as saying 2 into parentheses 2a plus 1, a plus 2b minus 2a minus 1. And on the right hand side, you're going to have 87. So writing this given equation, you can have 2 into parentheses 2a plus 1, a plus 2b. Looking at this, let's factor out negative sign. In the parentheses, you're going to have 2a plus 1 equals to 87. Now, from here, 2a plus 1 is common. So we're going to factor that out in the next slide. So here, we factor out 2a plus 1. I'm going to be left with 2 into parentheses a plus 2b minus 1, which is equals to 87. By distributing this, here we have 2a plus 1, 2 multiplied by a, we have 2a plus 4b minus 1, which is equals to 87. Now, I want you to recall something. Here we have that A and B are positive integers. So from here, that is, we have our A to be greater than 0, and also we have B to be greater than 0. Now, let's look at the factors of 87. We have 87. What are the possible two factors of 87? The first case, you can have 1 times 87, which gives 87. The second case is for us to have 87 times 1. The third case is for us to have 3 times 29. And the fourth case is for us to have 29 times 3. Now, let's look at these four cases. Which of these is more appropriate? If you look at this, this given equation here, this shows that this expression, for us to have 87, must be less than this expression, since both A and B are positive. So in that case, for us to have the first to be less than the second, we have this case number 1, and also we have this case number 2, where 3 is less than 29. So these are the two cases we're going to work with. Now, I'm going to start with case 1. Case 1 is when we have 1 times 87. So this given equation is going to be 2a plus 1. We have 2a plus 4b minus 1 equals to 1 times 87. Now, this shows that here you're going to have 2a plus 1 equals to 1, and you have 2a plus 4b minus 1 equals to 87. So from here, simplifying further, here we have 2a equals to 1 minus 1, which is 2a equals to 0. This implies that a is equals to 0. And in the second case here, we're going to have 2 into parentheses 0, since a equals to 0, plus 4b minus 1 equals to 87. So this is going to be 0. So here we have 4b equals to 87 plus 1. So here we have 4b equals to 88. And finally, we have b to be 88 over 4, which is 22. So in this case, we have the two values for a and b is going to be 0, 22. You can confirm this by plugging in these values into this given equation. If a is 0, then this is going to be 0. And when you plug in b to the 22 into this given equation, you're going to have 87. Now, let's consider case number 2. For case number 2, we're going to rewrite the same given equation, which is 2a plus 1, 2a plus 4b minus 1 equals to 87. So that case, we have 3 times 29. So I'm going to do the same. Here we have 2a plus 1, 2a plus 4b minus 1 equals to 3 times 29. So that is, for the first condition here, we have 2a plus 1 equals to 3. We have 2a plus 4b minus 1 equals to 29. So here we have 2a equals to 3 minus 1. 2a equals to 2. Dividing both sides by 2, here we have a to be equals to 1. While here we have 2. Since a equals to 1, in parentheses we have 1. Plus 4b minus 1 equals to 29. So here we have 4b plus 2 minus 1 equals to 29. Here we have 4b plus 1 equals to 29. So 4b is going to be 28. Dividing both sides by 4, we have b to be equals to 7. So for the first case, we have 0, 22, and for the second case, we have 1, 7. Thank you very much for watching. Please, if you have another suggestion to solve this question, kindly put it in the comment section. Thank you very much for watching. Bye.